Very good morning, my dear students. Okay, as we were doing complex number, and we have in the previous video we have started the complex number. I have taught you the basic things about this chapter, what actually means the complex number, and we have just started the exercise 5.1 from ML Aggarwal, volume 1. So let's get continue with that one. Okay, so as I see that some of the students are facing problem in the third question, which says that if z square equal to I, then is it true that z is equal to plus minus 1 upon root 2 1 minus I? This was the question. So how to solve this one? We are given if z square is equal to I, which is equal to, is it true that z is equal to plus minus 1 upon under root 2 1 minus I? So let us take this only and let us try to prove this equation. So z is equal to plus minus 1 upon under root 2 1 minus I. Let us square both the sides. So z square will be plus minus 1 upon under root 2 1 minus I the whole square. Now in the square, even if it is plus or minus, it will be positive only. So this plus minus sign will be removed. So 1 upon 2 1 minus I the whole square, z square 1 upon 2. A minus b the whole square identity is a square plus b square minus of 2ab 1. I square is what? Minus 1. 1 to 1 cancelled. Minus 2i upon 2. 2 to 2 cancelled. So finally you will get z square is equal to I. So yes, it is true. If z square is equal to I, then this is true. Like this you have to do the questions. Okay. Okay. Now let us come to the next kind of question. Find the real values of x and y if 3x minus 1 plus root 3 plus 2y times I is equal to 5. We need to find the real values of x and y. So for that, we need to compare the things. Now what I mean by comparison, whatever real part is here in the LHS, you compare it with the RHS, and whatever you have imaginary part in the LHS, compare it with the RHS. So as we see that we have real and imaginary part in the LHS, but we have only the real part in the RHS. So we write this 5 plus 0i. Can we write like this? Okay, now you compare real part with real part, imaginary part with imaginary part. So real part with real part will be 3x minus 1 equal to 5, minus 1 will go that side 6, x is equal to 2. And comparing the imaginary part there, it will be 0. So 2y equal to minus of root 3, or y is equal to minus root 3 upon 2. This is are they the real values? So yes, they are the real values of x and y. Similarly, you have to do the other question also. Say for example, if I mold this question as like this, that means we neither have the real part nor we have the imaginary part. So comparing with zeros, we'll get the answers of x and y correspondingly. Okay, let's come to this question. For any complex number z, prove that the real part of z, this is how we denote the real part. Real part of z is z plus conjugate of z upon 2, and imaginary part is z minus z bar upon 2. So let us consider z is equal to a plus ib, which is the general form, where a is the real part and ib is the imaginary part. So z is equal to a plus ib. Consider this as first equation. Find the conjugate of it. So conjugate z bar will be a minus ib. Consider that as second equation. Now add both this. So adding first and second, that is z plus z bar is equal to a plus ib, a minus ib. This ib to ib, it will be cancelled. You will get 2a, and 2 when it will come in denominator, so z plus z bar upon 2 is equal to a. So that means this is the real part, so real part is z plus z bar upon 2. Similarly, equation 1 minus equation 2 you will do, so z minus z bar is equal to this. So finally here a to a and plus of 2ib will be remaining. Take 2 in the denominator, so this is the real part and hence it is proved. Okay, now another kind of question. See, you are given this thing and you are asked to express this complex number in the standard form, that is a plus ib. So you need to express this whole expression in a plus ib form, the standard form of complex number. So first of all, removing the bracket, this minus will go inside like this. Now real part with real part will be operated and imaginary part with imaginary part will be operated. So finally we are getting this as answer, and we expressed in a plus ib, where a is minus 19 upon 5 and b is 19 upon 6. Okay, taking this question, under root 5 plus 7i and under root 5 minus 7i the whole square. If this is the whole square, so I'm taking one of its factor and one here, so a plus b, a minus b, a square minus b square. So it will be, this will be minus here, and one bracket is left here, under root of 5 minus 7i. Okay, so here what we have, this square with this under root will be cancelled. Just wait. So 7 square, 7i square will be 49i square, and this as it is. I square is what? Minus 1, so minus minus plus. This is as it is. This is 54, multiplying in the bracket. We got this as a answer. Okay, let us come to this question. Find the value of minus 1 plus root minus 3 the whole square plus minus 1 minus root 3 minus of root 3 the whole square. We need to find the value of this one. So first of all, what I'm doing, I'm taking minus 1 common, so 1 minus under root of minus 3 the whole square, and here also I'm taking minus 1 inside the square only. This will be 1 plus root minus 3 root of minus 3 the whole square. So this will be removed, as because minus of 1 square is 1, so whatever here, this is whole square and this whole square. Now using a minus b the whole square identity, a square plus b square minus 2ab and plus sign a square plus b square plus 2ab. So here as you can see, this with this it will be cancelled. 1 plus 1 is what? 2, and here minus 3 minus 3, so 2 minus 6 minus of 4. That is how we got. Okay, so this is a kind of different question for us to find the multiplicative inverse of minus of I. See, multiplicative inverse, I think we haven't taken this topic in the basic part, so let us understand with the question itself. So what you have to do in this question, if you want to find the multiplicative inverse of any of the number, then you consider that as z is equal to minus of I. Now as multiplicative inverse of z is z inverse, that is z to the power minus 1, so that is z to the power minus 1 can be written as 1 upon z. Okay, and z as we have minus 1, so 1 upon minus of I. Now I have explained you that in the denominator the complex, this imaginary number should not be there. So what you need to do, you need to rationalize this. So what will be the rationalization of minus I? That is I upon I. So this will be I and this will be minus of I square. Minus of I square, that is minus minus 1, so minus minus plus 1, so I. So the multiplicative inverse of minus I is I. Okay, understood? Okay, let us take one more question of this multiplicative inverse. Now you have to find the multiplicative inverse of 3 plus 4i. So z is equal to 3 plus 4i. Multiplicative inverse of z is what? Z inverse, that is 1 upon 3 plus 4i. Now to remove this from the denominator, let us rationalize this. On rationalization, that is 3 minus 4i upon 3 minus 4i. So this will be 3 minus 4i. A plus b, a minus b, a square minus b square. 3 square 9, 4i square is minus of 16, so minus minus plus of 16. 9 plus 16 is what? 25. Now separate it. 3 upon 25 minus 4 upon 25 I. So multiplicative inverse of 3 plus 4i is this. Okay. Okay, let us understand this question. If z is equal to 3 minus root 7i, then find modulus of z inverse. Okay, so first of all, let us find the z inverse, that is multiplicative inverse of z. So z inverse is 1 upon 3 minus root 7i. We need to rationalize this. So after rationalization, I got this as an answer, 3 plus root 7i upon 16. Now separate it. Now what does this sign shows? This is of modulus. Modulus means the absolute value. So we need to find the absolute value of z inverse. So it will be under root of the coefficient of a plus the a square plus the coefficient of b the whole square. So 3 upon 16 the whole square plus root 7 upon 16 the whole square, which gives, see, they both are of like fraction, so 16 square, 9 plus 7, 9 plus 7 is again 16, so 16 upon 16 square or 1 upon 16, and under root of 1 upon 16 is 1 upon 4. We won't write under root of 1 upon 16 as plus minus 1 upon 4. Why? Because this is the absolute value. So absolute value is in positive terms, so that is why 1 upon 4 is the absolute value of z inverse. Okay. Okay, so 31st question, that is I square plus I to the power 4 plus I to the power 6 plus I to the power 7 upon 1 plus I square plus I cube. So I square is minus 1, we already know. I to the power 4 is positive 1, that also we know. We are writing this I to the power 6 as I square whole cube plus, and I to the power 7 as I cube into I to the power 4 whole upon 1. I square is what? Minus 1. I cube can be written as I square into I. Now again, see this plus 1 with this minus 1 and this 1 with this 1, it will be cancelled. We know I square is minus 1, so minus 1 the whole cube plus I to the power 4 is what? 1, so I cube will be left upon I square is minus 1, so minus 1 into I will give you minus of I. Now minus 1 whole cube is minus 1, I cube. I cube, can we write this I cube as I square into I, and I square is minus 1 into I, so you will get I cube value as minus of I. Okay, then here, now in the denominator you have the imaginary term, so let us rationalize it, multiplying with I upon I. Now multiply this I with this one, so it will be minus I square upon minus of I square. Minus 1, what is minus of I square? It will be positive of 1, so plus 1 upon plus 1. Finally 1 minus I, this is the final answer. So that's it for today's video, my dear students. I hope you will practice, and I expect that you should practice. Alright, so do practice, and if you have any doubt, surely we'll discuss in the video itself. So I have done till 31st, so I expect that you also should do up to 32 or 33, because those are very easy to solve. I don't think you will face any problem if you have gone through these two videos very thoroughly. Alright, so till that, do practice. Thank you so much. Bye bye, have a nice day.